Hello and welcome to another modelling video. Today I'm going to do another one of those experiment videos, and this time it's playing with the Chise Project. A while ago I scratch built her wings, or the frame of her wings, out of metal, and would like to take you through that process. Again, I'll ask you guys not to take this as a tutorial but a suggestion of how I got around this matter. After I did my research many videos ago, I sketched roughly what I wanted and broke down the pieces to individual pieces that were realistic to cut out onto paper, and gathered a heap of tools including a rubber mallet, tin snips, a scribe and some other useful elements. I traced the images I wanted onto another piece of paper and cut them out with scissors. I'm going to be gluing this paper onto the metal and in preparation to start cutting the shapes out. The hilarious nature of this task is it's a type of activity you should be pulling off in primary school or kids' crafts, yet it's still fairly effective for what I'm doing. With only white PVA glue on hand, I use that to glue the paper onto the metal in hope that it'll peel off easily later. And when placing all the paper on the sheet of metal, I try to waste as little material as possible, yet have enough clearance space to cut, since it is difficult to cut metal. The complete parts layout in both styrene and metal. I'll also suggest to you guys that you can do the same thing with styrene, but you're able to actually draw directly onto the plastic with a grey lead or graphite pencil. When choosing metal as the material, it's best to choose something that's no more than a couple of millimeter, otherwise tin snips won't cut it. Tin snips is like scissors designed to cut into thin sheets of tin or brass or copper, and can be bought from your local hardware store. At the moment I'm only cutting in large chunks, and then I'm going to shave it down to closer to the piece, since it really shears the metal instead of cuts like scissors on paper or plastic. And because the metal is sheared or torn, it's going to give you a warpy, bent effect, which you most likely want it to be flat and straight. So we're going to be panel beating it using our rubber mallet. Just remove the paper pattern off the material and we've got our cut shapes. All you have to do is lay these pieces on a flat table and flatten them with your rubber mallet. And if you want them to even get flatter or refine it a bit more, put a large piece of surface, plywood, plastic, whatever, and flatten it or hammer it flat. This might take a while. Another amazing attribute to metal is we can either weld or solder pieces together to it, or even bend the shape or warp the shape into a circular or bent corners as we choose or please. We can get an automotive dolly or a mini anvil and beat it to shape with a rubber mallet, but all I want's a 90-degree angle, so all I'm going to do is put it in a vise and hammer it into that 90-degree fashion. We're also free to use the scribe to put in faint lines so we can cut it down or detail it further. Now our biggest question is how we're going to stick all these pieces together. I'm going to be using slow drying epoxy glue. It's a 2-part glue with a resin and a hardener, and this is a lot better than super glue, which is an immediate contact but really good for a lot smaller pieces, as it's going to make the piece solid and not break easily at all. Now we have our basic shape, but remember it's quite flimsy, and in your design you probably want to reinforce it further with putty or thicker styrene to retain its shape, so it's not going to be bending or breaking any time in the future unless you want to have a fragile model. Sheet metal can be an extremely difficult material to work with many disadvantages. Mostly what I haven't covered yet is weight, particularly with building humanoid robots. If you're going to put a large backpack or wingspan like I did, it's going to be back heavy and fall over all the time. Though due to this particular project, it's not an issue at all. Though you have many fantastic advantages, such as it complements well with plastic and putty in producing the perfect scratch building detail when you're really venturing far into the hobby. And if you're skilled or good enough, you're able to incorporate the natural finish of metal in your kit. But the biggest selling point to me is the fact that it's quite strong and can reinforce any part as an armature. And on top of that, its flexibility is a lot better than brittle styrene, as I can stretch it or bend it to any shape that I desire, including circular motions that you'll never achieve with styrene, even though you go to the effort of heating and bending, which is near impossible to achieve to perfect specifications. Before I finish, I'll mention or highlight the importance of using an etch primer or a proper lacquer primer on top of metal, as paint does not adhere to it very well and will rub or remove off. Thank you for watching, and until next time, I hope this video inspires you to go out and play with a little metal in your scratch building projects. See ya!